All right, this is the volume review worksheet, and on the front side of this worksheet we have six different shapes. We actually have two rectangular prisms, two triangular prisms, and two cylinders. And so these are the shapes we've been working the most with during our volume and surface area unit. And so I'm going to review how to do one of each of these, and I'll start with the triangular prism from number 2. And so again, when I'm finding the volume, this is different from surface area. It's a lot easier than surface area because I only have to do the area of its base times the height. And so in a triangular prism, the base has to be the triangle side. And so when I do the area of my base, my formula for an area of a triangle is 1/2 times the base of the triangle, which is 12, times the height of the triangle, which is 9. And then once I find the area of that base, I have to multiply by the height of the prism. Now this is where it can get confusing. The height of the prism is not 9. That was the height of the triangle. The height of the prism in this case is going to be 6, because 6 is how far apart the two triangle sides are. There's one triangle on the front side, and there's one triangle on the back side. And so the height is always the distance between the two bases, which is 6. Interestingly, I don't actually use the number 15 at all in this problem. Remember, this is the same worksheet that you were given for surface area, and so we would have used the 15 if I was finding the surface area of this shape, but we're doing volume this time, so I can ignore the 15. So let's start with doing half of 12. Half of 12 is 6, and 6 times 9 is 54. And then so 54 times 6 gives me my volume. And 54 times 6 is 324, and because it's volume, we're going to be measuring in cubic units, so meters cubed. So find the area of your triangle base, and then once you have the area of your triangle base, multiply it by the height of the prism, which in this case was 6. All right, so the next shape that we're going to do is number 3. It's this rectangular prism here. And for number 3, we're going to do use the same volume formula, except our capital B is not going to be 1/2 BH. Our capital B is going to be the length times the width. And so I can actually choose whatever side I want to make the base of my rectangular prism. For example, I don't think I've done one of these sides yet. Let me just do the right side. Let's use that as the base. To find the area of that rectangle, length times width would be 11 times 5. And the distance from that side of the rectangle to its other base on the other side is 15. So rectangular prisms are the easy ones where you just multiply the length, the width, and the height together, and it doesn't matter what order you do it in because it doesn't matter which side you refer to as your base, unlike the triangular prisms where we have to make the triangle sides our base. So we can do 11 times 5, which is 55, and then 55 times 15 is 825, and we got millimeters here, so millimeters cubed. All right, the next shape that we're going to do is actually number 4. Number 4 is an example of a cylinder. And so the cylinder uses that same formula of V equals capital BH, but my capital B is now going to be a circle. So I'm going to use pi r squared for the area of my base, my capital B. The radius of this circle is 9 because the diameter, which they're giving me that dotted line that goes all the way through, the diameter is 18, which makes the radius 9. So pi times the radius squared times the height of the cylinder, which is 11, because the distance between the two circles is 11 here. So 9 times 9 is 81. 81 times 11 is 891, so I'll write that down, 891. And really, you could do all these steps at the same time. You don't even have to write the 891 pi down. You can just go ahead and multiply by 3.14, and that's going to give us 2,797.74, and we're doing cubic centimeters, so centimeters cubed. So the area of our circle was pi r squared, right? So we used 9 for the radius, and then we multiplied that by 11, and that gave us the 2,797.74 centimeters cubed. So there's 3 more shapes on this side. I've done 3 of them for you. And so you need to do the number 1, number 5, and number 6 on your own. All right, on the back side of this worksheet, we have the four shapes we've looked at on the surface area, but when we do the volume of these four shapes, it's going to be a lot easier to do. So I'm going to look at number 7. Number 7 is a trapezoidal prism, and we did an example of a trapezoidal prism in our notes, but I'm going to find the area of my trapezoid base that I'm highlighting right here in red, and then I'm going to times it by the heights, because even a trapezoidal prism uses the same formula of capital B times H. Capital B is, because it's a trapezoid, is going to be 1/2 base 1 plus base 2 times the height. And so all of that will be capital B. And then once I find that, I'm going to times by the height of the prism, which I'm going to color that H blue so you don't get those H's confused. That H refers to the height of the prism, which is how far apart the two trapezoid sides are, which is actually 6. We can see that right now. So let's go ahead and plug in the numbers for B1 and B2. The bottom base of my trapezoid is 9, and the top base of my trapezoid is 5. And the height of the trapezoid is this 4 centimeters right here. We have that right angle that tells us that's the height. And so actually don't use the 7 or the 8 at all. I used those when I found the surface area, but I don't need them for the volume. So 9 plus 5, let's do that first. 9 plus 5 is 14. Half of 14 is 7. And so 7 times 4 is 28. So all of this is 28. But I have to, once I find the area of my trapezoid, I have to times it by the height of the prism, which is 6. So 28 times 6 gives me 168 cubic centimeters. Now, I'm going to let you do 8, 9, and 10 on your own, but I can give you a few pointers for 8, 9, and 10. Remember, number 8 is a parallelogramal prism, and the formula to find the area of that parallelogram base is still just base times height. So I'm going to use the volume equals area of the base times the height. And to find the area of the parallelogram, I'm going to multiply the parallelogram's base of 13 times the parallelogram's height of 6. And so once I have that, I just have to multiply that by the height of the prism itself. And that height is going to be the distance between the two parallelograms. On number 9, probably the easiest way to think of this is a rectangular prism, which you can easily find the volume of, length times width times height, combined with sitting on top of it is a triangular prism. So we did this with area. If you remember, when we were doing composite area, we combined, once we found the area of one shape and the other area of the other shape, we combined them together to find the area of the total. Well, this is a composite three-dimensional solid figure. So you're going to find the volume of the rectangular prism, find the volume of the triangular prism, and just add them together. And you're going to do the same thing for number 10, except number 10, they're both rectangular prisms. So you're going to find the area or the volume of this rectangular prism that I'm highlighting on bottom here. And then once you have the volume of that rectangular prism, add it with the volume of this rectangular prism, which is sitting on top right here. Sorry, that's not a good job of highlighting. But you're going to find the volume of both of those, and then again, just add them together to find your composite volume. So let me know if you have any questions over this. And again, you're responsible for doing the 3 problems I left for you on the front side and these 3 problems on the back side.